Okay, so a person wants to buy a pension which will provide an income of 10,000 at the end of each of the next n years. With a steady rate of 5% per year, we've got to show this. Okay, well, it's worthwhile working out in small steps. So we'll start off by thinking about the amount needed for 10,000 after 1 year. And that obviously won't be 10,000. That obviously won't be 10,000 because after 1 year, the money I've got now, I'm going to earn some interest. So the amount of money I needed, but if I include the interest, I need to times that by 1.05, and that must be equal 10,000. So it won't be 10,000; it'll be a bit less than 10,000. And should we call the amount needed for after 10,000 for 10,000 after 1 year? If I call that x1, and then that means x1 times by 1.05 equals 10,000, and therefore x1 equals, I need to divide both sides by 1.05, which is actually exactly the same, obviously, as timesing by 1 over 1.05. And that's begun to start looking like something in the formula I needed. So the amount needed for 10,000 after 2 years, well, obviously we'll call that x2. But now it's got 2 years interest, so we can still got compound interest. And if I times that by 1.05 squared, that's going to have to give me 10,000. Therefore, obviously, x2 equals 10,000. We've got to divide both sides by 1.05 squared, or it's the same as timesing by the reciprocal of 1.05 squared. And so that does it like so. And then obviously x3, that's the amount needed for 10,000 after 3 years. That bit will be 10,000 times 1.05 cubed. And it goes all the way down there. And then we finally get xn equals 10,000 times by 1 over 1.05 to the power of n. And if we add up all those, then fairly obviously, so total amounts equals x1 plus x2 plus x3 plus plus xn, and that equals x1 is 10,000. Oh, I can take a factor of 10,000 out of all of them, and x1 would be times 1 over 1.05, and then we have to adding this. We're adding these together. 1 over 1.05 squared plus 1 over 1.05 cubed plus plus 1 over 1.05 to the power of n. And that's what's required. So now we need to find a simple formula for calculating this sum. We've got geometric progression here. So we've got GP, and the A is the first term. Well, I've got 10,000 times, to be fair, the sum of this this geometric progression. So A is the first term, which is 1 over 1.05, and R is what we times by each time, and each time we're timesing by 1 over 1.05, and then I want n to be 10, 20, 30 equals 10, 20, 30 up to 50. So the total is 10,000 times, and then I've got the sum of n terms, so it's A, which is 1 over 1.05, times by 1 minus R, which is 1 over 1.05 to the power of n. We'll take 10 to start off with, and then that is all over 1 minus R, so 1 minus 1 over 1.05. And if I put that into a calculator, I get 77,217.35. That's what I'd need for 10 years at £10,000 per year. And then for 20 years, I just have to put exactly the same formula in. I might as well go back and replay it, and instead of typing 10 there, it needs to be 20. And that'll give me £124,622.10. And then the next one, when it's 30 years, will give me £153,724.51. And then 40 years. So I'm just changing that 10 there, so it's now 40. Or in fact, just changing the 1, so it's now 4. That equals £171,590.86. And then finally, the last one, 50 years, is £182,559.25. And that will do it all. It's done.